We're going to talk about certainly one of my favorite subjects, the evolution of the Jupyter notebooks, which are, as everybody knows, totally awesome. Thank you.
Thanks so much. It's great to be here at PyData this year. We've been coming here to Microsoft for a couple summers, and it's fantastic to see Microsoft embracing the Python ecosystem, the PyData conference series, and NumFocus, which is behind the PyData conference series. And today, I want to talk to you, or we are going to be talking to you about JupyterLab. My name is Brian Granger. I'm a physics professor at Cal Poly and a longtime Jupyter contributor. And also with me today are Chris Colbert from Continuum Analytics and Ian Rose from UC Berkeley. And we're going to be talking to you about JupyterLab. Also, before I started, I want to give a huge shout out to the larger Jupyter effort, both the folks that are listed here by name working directly on JupyterLab and the larger Project Jupyter. And I want to go over here. For those of you who don't know, Project Jupyter is led by a steering council, and the current steering council is shown here. There's 15 of us. These are basically the long-term contributors to Project Jupyter. And all that we do would not be possible without the steering council here and also many, many other contributors. These are by no means the only contributors to Jupyter. These days we have around 25 full-time people working on Jupyter and then dozens of other contributors as well. And then also our funding sources. In particular, right now at Cal Poly in Berkeley, we have funding from the Helmsley Charitable Trust, the Alfred P. Sloan Foundation, and the Gordon and Betty Moore Foundation. We've also had funding in the past from Google and Microsoft. There's ongoing funding from the EU, Rackspace, Fastly, and then we have a number of other institutional partners, Continuum, Bloomberg, Netflix, Cal Poly, Berkeley, and QuantStack, who are all contributing basically developers to the effort. And all of what we're talking about today and the rest of Jupyter would not be possible without all of this. So first of all, the Jupyter Notebook. The Jupyter Notebook originally came out in 2011. And it's an environment for building what we call computational narratives. This is a web application that's focused on interactive, exploratory, and reproducible computing. The notebook document allows you to combine live code with narrative text, equations, images, markdown, visualization. We support over 50 programming languages. I think this is completely out of date. It's probably getting up towards 100 different programming languages now. Everything we write is BSD open sourced. Here's a screenshot of what we're now referring to as the classic Jupyter Notebook. Many of you have either used it or have seen it being used here at PyData this week. And in this example, you can see this document which contains code and then a visualization. And this is one amongst many examples in the Jupyter Notebook. So taking a step back from the notebook, where are we today with Project Jupyter? Our best guess is that we have over 6 million users. It's really tough for us to get an exact count on this. We did a UX survey in 2015, and this visualization here shows a rough segmentation of where different users are coming from. No great surprise, data scientists, students, researchers, developers, engineers, educators, are dominating our user base. Currently, there are over 1 million public notebooks on GitHub. The foreground chart here shows the number of notebooks on GitHub, the number of public notebooks on GitHub over time. It's growing very fast, and we do know that there's likely another roughly 1 million private notebooks on GitHub as well. If you want to see some of the interesting notebooks that people are creating these days, there's now a Jupyter Notebook category on GitHub. So if you go to GitHub Trending and search for Jupyter Notebooks, you can find what the interesting repositories with notebooks are for the last, I think it's day, week, and month. Jupyter is enabling reproducible science. A great example of this is the LIGO collaboration, which has announced the observational discovery of gravitational waves due to the collision of very distant black holes. And as part of this, LIGO has an Open Science Center. And in their Open Science Center, they're posting Jupyter notebooks, which completely reproduce their data analysis, going from the raw gathered data to the final visualizations that go into their papers. And we're really excited when they started to post their sort of their computational materials that supplement their publications. And one thing that's happened over the last 2 years is not only can people read the notebooks that they've written, but it's very easy to actually run the notebooks that they have written as well. And this is one way that you can do this is due to a project called Binder. Originally, this started in the group of Jeremy Freeman at Janelia Labs. Now there's an ongoing partnership with the Jupyter Hub team in Project Jupyter that is basically building Binder on top of the Jupyter architecture. And so I can go here and actually show you an example of this. So if I go to this web page, this is the binder for the LIGO Collaborations notebooks that has the analysis. So what's happening here is Binder allows you to point to a GitHub repository with notebooks and a file that declares the dependencies. Typically, this is a requirements file for pip or a conda-env file. And then Binder automatically builds a Docker image and deploys that Docker container based on the image with a live running notebook server, all the dependencies for that repo, and all the notebooks in that repository, and all the other files. So here, anyone on the internet can click on that link and go to a live binder, as we call it, that allows you to look at and fully reproduce and run the analysis that the LIGO collaboration did. And so we're really excited about how this is making science more reproducible. This also extends to other areas. Obviously, it extends to data science. It extends to data journalism. Here's a really nice article that came out of BuzzFeed in 2016. They've got a great data science, data journalism team at BuzzFeed. The consumer-oriented article was on match fixing in tennis. And you can see that in the foreground. And then along with every data-oriented article they publish, they have a GitHub repository that contains the data for the article and then the full analysis as Jupyter notebooks. That's another great example of reproducibility in this space. Project Jupyter is also enabling interactive books. O'Reilly Media is embracing Jupyter, the Jupyter architecture, and Jupyter notebooks at a very deep level, both in their blogging platform, in their authoring platform. So you'll start to see a number of books now, a number of O'Reilly books that are shipping with accompanying Jupyter notebooks along the way. Sometimes they're secondary, sometimes the books themselves have been wholly or partially authored using the Jupyter notebook. One way that we think about Jupyter now, as time has gone by, is in terms of building blocks for interactive computing. You may already know that the classic Jupyter notebook offers more than just Jupyter notebooks. It offers a file browser, it offers a text editor, it offers an in-browser terminal, in addition to Jupyter notebooks. And so for a long time, we've had these other building blocks. In a classic Jupyter notebook, it's always been a little bit painful. You could really only have one of these activities or building blocks on a single web page. While useful, it's made it very difficult to integrate the building blocks and assemble them in interesting and new ways to support different workflows. So here's these building blocks: file browser, notebooks, terminal, text editor, kernels, output. And so what are we hearing from users that's driving the development of JupyterLab? Some of this is based on our talking to users in person, watching users work, seeing what people are doing with Jupyter. But we also did a UX survey in collaboration with IBM in 2015. And here are some of the results we heard. First of all, folks who use Jupyter do so quite often. It tends to be the type of software that they work in a lot, daily or weekly. It's not something they touch once in a while. Part of what this means is that if we have painful user experience, users are going to hit that time and time again. And so it's really important for us to think carefully about user experience. In general, our users love the notebook experience and don't want that to go away. That's very non-obvious. We've rethought a lot of things in JupyterLab. We could have thrown out notebooks, but based on our experience, that's not something we've done. And so JupyterLab still has the same Jupyter notebooks that our users are using and have loved and find productive. So what were some of the top needs that users have expressed to us? One is integration with version control systems, Git and GitHub in particular, improved code and text editing, and really what's behind this is that as users work interactively in notebooks, eventually they start to do something that looks more like software engineering, right? Eventually they're going to need to take content that's in a notebook cell, move it to a text file, start to write tests, put it in a Python package, something like that. And so having tools that allow for a more seamless transition between these different workflows is really important. Another is getting past this limitation of one notebook per page. We have had a lot of very patient users and developers extending the notebook, trying to get other user interface elements in the notebook. So sometimes people are sort of ramming entire user interfaces inside of the output of a notebook. You can do it, but it's really not optimal. So one of the things we've needed is a more flexible layout system for the web application that allows for integration between the building blocks. Another big area was more sort of standard traditional IDE style features, so debugging, profiler, variable inspector, and so on. And this is not the first talk where we've mentioned JupyterLab. I think what's fun about this talk is that we're almost to the point where we would recommend that you go and download and use JupyterLab. We're expecting to release a beta in the next few weeks. And as of the beta, we are going to recommend users start to use it for daily work. The main reason we're calling it a beta still is that the APIs are not quite stable. And in particular, that's relevant for people who want to extend JupyterLab with their own customization. So think of the beta of JupyterLab that's coming up as a sign that you should start to use it and install it. With that said, you can pip install or conda install JupyterLab today. If you're willing to be patient with us as we break lots of things and fix lots of things, we encourage you to do that and give us feedback. And the best way to communicate what JupyterLab is to actually give you a demo. And so in just a second, I'm going to bring Chris Colbert up to give that demo. Before I do that, I want to mention JupyterCon. So we're having our first Jupyter conference in New York City this August. This is co-sponsored between O'Reilly Media and the NumFocus Foundation, of which Jupyter is a part. And we've got an absolutely spectacular program that covers Jupyter and then sort of the broader ecosystem of data science. So there's a number of talks on AI and machine learning, and then really interesting talks about how are people using Jupyter in real life organizations doing data science. And so I encourage you to check out JupyterCon if you're interested in learning more about Jupyter. And with that, we're going to have Chris come up and give you a demo of JupyterLab. Great. There we go.
Perfect. Thanks, Brian. Good afternoon. As Brian said, my name's Chris Colbert. I'm a software architect at Continuum Analytics, and I'm about to break every rule in the book by giving a live demo of an alpha product. So all the usual disclaimers apply with that. So Brian, he kind of mentioned that we consider Jupyter and the things that Jupyter provides building blocks for scientific computing. And what we really wanted to do with JupyterLab is bring all of those building blocks under one roof so that you can use them together. It's easier than having separate browser panes open across different monitors and different windowing systems, all that kind of stuff. And so I kind of just want to start by running through the building blocks that we offer that are all under this one roof. So when you start JupyterLab, you're going to see something similar to this. It's called our launcher page. One click to start a new Python notebook. If that's not enough, I can open a new launcher. I can one click start a Python console. This is going to be similar to a Qt console if anybody's ever used that in the classic IPython Qt console stuff. We also have live terminals. So this is running in a web browser using term.js. I actually have full Unix terminal access inside of the browser now. And we have text editors. These are kind of the default kind of building blocks that we have that you're allowed to create and manipulate inside of JupyterLab. But one of the things Brian also said is that your notebooks are still notebooks. So JupyterLab wouldn't be that useful if we couldn't completely recreate the notebook experience that you're used to in the classic notebook. And so we spent a lot of time. It's a brand new implementation of the notebook, so the notebook front end is completely new. It's not actually the classic notebook, but it has almost all of the features at this point of the classic notebook. So I'm going to open a reasonably complex notebook at this point. And it's all the stuff you're used to seeing in the regular Jupyter notebook. We have tables, we have rich output, we have mathml, we have pandas data frames. But since it's a brand new front end and we were able to do things a little bit differently this time, we've added new sorts of things. So we can now expand and collapse cells, which was a big feature people have wanted for a very long time. One of the other features people wanted is the ability to drag and drop cells. So now I can take a cell and I can start moving it around the notebook into a new position where I want it to be. So your notebooks are still notebooks. It's going to be a familiar interface, but now with lots of feature improvements and lots of more feature improvements planned, because now we're built on an architecture that actually allows us to implement those and build in those nice new features. One of the things that we also do a lot of in data science is writing a lot of Markdown. So I'm just going to open a little demo Markdown file right here. And so you might write something like this, where you're trying to explain some sort of Python data science. It might have some inline Markdown examples. And what you might want to do in a classical workflow is open a Markdown preview that might be in a new, I don't know what's going on with my alpha software. Here we go. All right, let's try this again. When in doubt, refresh the page. There we go. So you might find yourself writing some Markdown code, having a Markdown preview in another page, and switching back and forth. And that's kind of what we were trying to get away from. If you remember what Brian was saying, is that people wanted to have multiple notebooks on one page or multiple building blocks on the same page. And so what we've built basically in parallel with JupyterLab in a project that I'm the primary author of, it's called Phosphor.js. It's a lower level JavaScript UI toolkit library for building applications that are like JupyterLab. So as we were building JupyterLab and we were finding that there weren't necessarily JavaScript libraries in the open source world that did what we needed to build this type of application with the performance that we wanted, we did what any self-respecting computer scientist would. We went off and built our own. And we made it a separate project so that people that want to build applications like JupyterLab but that aren't exactly like JupyterLab, they can do that. And so, one of the things that that library provides us is a more advanced windowed docking system. And so I can actually take my live preview Markdown and I can stretch it to the side and I can actually put it parallel right next to my other documents. And what's really cool about this is that everything that we're seeing in all of the data models that we have driving these Markdown files in the live preview, they're all interconnected. So as I edit this Markdown file, my live preview updates at the same time. So now instead of having to go through a build, compile, switch tabs, look for my different, compare my output, go back, edit some more, I can do it side by side in the same panes. Another new feature that we built in to our Markdown viewer is we can actually create a new code console that's attached to that Markdown viewer. And it might be really cool if I just kind of put this over there where I have a little bit more screen real estate. And once I have actually a code console attached to my Markdown file, I can go to my little blocks of Python code that are right here, and I can shift enter and send that code to my console and have it execute. And so now I can write my Markdown file, and as I'm writing my Markdown file, I can actually test my code and run it in the console. And if I want to play with that data, it's still there. This is a live console, so I can, I can type in whatever I want to do, inspect my data, play with it in the console, and do all that sort of stuff. And this console might get really big as I'm doing things, so I might want to expand it to take up more of my screen real estate to see some things temporarily. So we have a shortcut for that, where I can just quickly snap into what we call single document mode, where the pane that I care about in my little main docking area is the most important thing to me at this particular moment. And so I can expand that to take up the whole space. But at the same time, I don't want to lose the ability to go back and see my previous context that I was looking at. So what we have is a little tabs bar over here that allows me to switch between the other open documents that are still in my session, basically. And when I'm done looking at this single document mode, I can immediately switch back to the same layout that I was in before. Some of the other tools that we built into the system that allow you to just get around the environment and work with your data in a friendly way. You've seen me playing around with this file browser. I'm actually going to call it now. This is the file browser that we have. We've got some breadcrumbs at the top that allow you to basically navigate through anything that's actually from the root of your Jupyter Notebook server, anything that server is serving up to you, we can actually browse through in this, in a regular file browser. So it's a control that you're going to be pretty comfortable with. It's pretty standard things. We have the ability to, if I find the right file here, I have the ability to drag and drop and move stuff around in my file browser, all sorts of normal things. We've also got a running tab that tells me what sort of terminal sessions, what sort of notebook sessions I have up and running, and we've got a standard command palette, and anybody that's used Sublime Text or VS Code is going to be familiar with something like this. You can filter it to do things like fuzzy search, I want to launch a new terminal, those sorts of things will open for me. So this is all pretty well and good, and I can work in this environment, and I can see the data that's in there, and I can edit some data, I can create some things. But what if I had something that is, let me see if I can get out of this full screen here. There we go. What would you do if you had like a 200 megabyte CSV file that you wanted to open? I happen to have one of those on my desktop, and I think what most people might do is they might just double click on it and try to open it in Excel. And I'm going to let that run for a little bit because it's like 1.2 million rows, and it's going to take a little bit for Excel to do that. And while that's going, I'm actually going to go find a slightly smaller data set that I have on the system here. And we'll go ahead and open that up. And I don't know, this is a couple thousand rows. And what this opened in is our new CSV viewer. If anybody's used to the classic notebook, that opened almost instantaneously. In the classic notebook, you would have gotten a pager. It would have taken 30 or 45 seconds to load, and you would have had to page through 1,000 rows at a time. This little CSV viewer, grid viewer thing is a new widget that we're building in Phosphor.js. It's still very much beta. There's lots of features that we want to add to it still. But it's extremely high performance. It's all rendered in Canvas. We can scroll through nearly infinite data sets. I think Excel is done now. So 200 megabyte Excel file, Excel's like, sorry, can't load it completely. So let's go ahead and see what it did. And it shows something. It doesn't show all the data. And as I try to scroll through it, it's really janky. It's not a very nice user experience. So let's see what JupyterLab can do with that same file. So let me go up here. So this is that same 200 megabyte CSV file. Might take a couple seconds. It's pulling 200 megabytes over the network and putting it into memory. But it loaded in about 8 or 9 seconds. And it's 1.2 million rows, and I could take the scroll bar and page through it in real time. So we don't need a pager anymore. We don't need any sort of the clunky grid tools that you usually do to deal with big data. You can just throw your entire data set at the data grid and render it. And if your data set is bigger than 1.2 million rows, I have what I call the keep me honest example, which shows a couple of different things. I've got a couple different grids here. Got some streaming data rows. I've got some things that are updating one cell at a time. But I think one of the most interesting one here is in the top left corner, this is a data grid with 1 trillion rows by 1 trillion columns. And I can scroll through that in real time. So there's still, thank you. So there's still lots, again, this is like 0.1 release. We don't have selections, we don't have editing. There's lots of stuff to do, but the graphics pipeline is in, the high performance rendering is in, and so we can scale. And we can still scale with a trillion row data grid and have variable size rows and columns, by the way, which is where most all the other large scale data grids fall over. So that's kind of where we're going in the high performance data visualization, grid rendering kind of stuff. But aside from CSV files and fancy grids, what other kind of support for files do we have? So probably lots of things that you typically expect. Let me go back to my data file here. I can drag and drop from the file browser, get some more screen real estate. So we have images. Our image viewer, it's got some basic zooming features in it. I can plus, minus, zoom in and out. I get scroll bars, all that kind of stuff. And we've got support for GeoJSON files. So if anybody's familiar with GeoJSON, it's a JSON representation of geography, and so we can load that in a leaflet viewer and actually have a map using leaflet. So that's all well and good. And in the previous talk, they had mentioned Vega and Vega Lite for doing graphics, and so we actually do have support for Vega and Vega Lite. We probably need to organize these things a little bit better. to examples. There we go. Okay, so I can just take a Vega Lite file, drag and drop it into JupyterLab, and I get my plot. And this is great, but what if I want to actually see what the JSON is that's loaded under that covers? Well, I can right-click on my file browser, and I happen to have another file opener that can handle Vega Lite JSON files, because it's just regular JSON, and I can open it with our JSON viewer. And our JSON viewer allows us to view this data as an interactive tree. So I can actually interactively browse the JSON that's making up this Vega visualization. But as I mentioned before, the data models that drive these, so the data model that drives this JSON viewer, the data model that drives the Altair visualization, all of those visualizations are sharing the same underlying core data model that's running inside of JupyterLab. So I can actually open this same JSON file with my code editor, view all three simultaneously, and if I want to go down and change the marks that are rendered in this Vega Lite file, I can just type in my editor, and as I make the edit, the plot's going to update, my JSON viewer is going to update, and the file is going to automatically be saved back to disk. So we've kind of tied all of these concepts together under one roof, and all of these building blocks can now communicate and act together. And I think at this point, it's now good to hand it off to Ian, who's going to talk to us about the next level of interaction, which is the real-time communication we built into JupyterLab.
Thanks, Chris. Brian, you said you had a...
Down lower. Right above the trash.
Found it. Okay.
That's you.
Sorry, I'm not a Mac user usually. Okay. So, so one of the most requested features that we get for Jupyter Notebooks is better tools for collaborating with people. And to that end, we've been attacking it from several different angles. We're trying to add better Git support and GitHub support into our user interfaces. We're trying to add better support for diffing notebooks and looking at conflict and looking at, you know, if you've what kind of changes you've made to notebooks. And there's the third aspect of that, which I'm going to be focusing on today, which is real-time collaboration. Now, all three of these different modes of collaboration have one thing in common, which is conflicts. And you could interpret that in sort of more of a sociological way. But by conflicts, I mean just if two people are editing the same document in the same place, those edits are in general going to conflict with each other. And so we need some way of dealing with those conflicts. And the way that most people in this room are probably familiar with is Git conflicts, right? You have two different commits, and those commits touch the same area of code, and you have to deal with those. And you may have various tools for dealing with those, but for the most part, you have to do them manually. When you're editing documents in real time, the conflicts you run into are of a different sort of beast. And the reason is because the most common way we interact with our documents is by typing text. And the text that we enter has to feel seamless, and it can't have any kind of errors in it. So if there are any conflicts that arise and we have to deal with them manually, your editing experience is going to be horrible, and you're not going to want to use our tool at all. And so if we want to have real-time collaboration on any kind of document, we need some way of handling those conflicts correctly, seamlessly, and extremely quickly. So that's a very challenging problem, and there are a number of different ways you can approach it. One popular way is called operational transforms, which is the algorithm that underlies Google Docs and is also underlying what I'm about to show you today. So what we've been working on for the last several months is a plugin for JupyterLab, which uses Google Drive as a store for notebooks. Most people have probably used Google Drive, but maybe have not dug into the API much. But it does expose a nice, rich API, and that API provides the same type of primitives for doing real-time conflict resolution that you would see in, for instance, a normal Google Doc text editor. So if you look at what I'm clicking on here, this is an alternative file browser, which is currently logged into a Google Drive account, and we've set up a couple files that we're going to look at in a moment. So this is the same file that Chris showed earlier, which is that Markdown file, and I'll open it first as Markdown, and also, are we running into the same thing as previously? It might be the full screen. Okay. How do I exit full screen on this? Okay, thanks. Okay, so this is the same Markdown document we were looking at previously. We've got side-by-side panels of the rendered and unrendered version, except for this Markdown document, it exists in Google Drive, and so you can see that there are some edits going on in that document, and I'm not doing them right now. So you see there's a couple different little carrots going around there, adding Python code. That Python code is getting rendered in real time. If I hover over those carrots, it'll give me the names of the people who are editing them. So Chris and Brian are both in there right now, editing this document. I've also got a chat panel on the side here. Brian is giving me a little pep talk. Yeah, so this is a Markdown document. It works pretty well. At the end of the day, though, Markdown isn't really our bread and butter. Our bread and butter is interactive computing. So let's take a look at what this looks like if we have a notebook. So here's a notebook I whipped up last night. It solves the one-dimensional thermal diffusion equation. This is the equation that Fourier worked on when he invented Fourier analysis. We can open up the chat panel here. And Brian is helpfully letting me know that I've put the wrong equation for, for the thermal diffusion equation. I've actually put the quadratic equation in there. So that's a mistake. But in the chat box, he's helpfully given me a correction for that equation. So I can actually take that chat entry and click and drag it into the notebook and get the right equation in there. This is now just a regular Markdown cell, so I can double click on it and you can see that it's just a LaTeX equation there. Okay, so now that we've got the correct equation, let's run this notebook. I'm not going to talk about the specific numerical methods because that's not what this is about. Well, interesting. Looks like we don't have the proper matplotlib library here. I think we should be able to recover from this particular error, though. Thanks, Brian. OK, so that is, again, not something I did there. Brian actually ran the notebook on my laptop over there, which does have the correct matplotlib version. And that created this animation, pushed it across the network, and then rendered in real time in this notebook without me really having to do anything. OK. You can see that the basic editing of the notebook is the same style that you saw in the text document. Here's Chris's caret, and he could, if he feels like it, change. Or have you already done that? Yeah, Chris has already changed it to a different initial condition. So if Brian runs it again, we should see it updating to a different function. Oh, there we go. So whereas before it was a sine wave, now it's a cosine wave. So this project for doing real-time collaboration is still very much an alpha product. It's changing quickly, but it can be used today. So if you feel like downloading it and giving it a spin, back up your notebooks and then try it out and let me know how it goes. And with that, I think we can probably take questions.
Yeah. One thing I wanted to mention before we get right into questions is that everything we've shown here today, I didn't mention it in my segment of the talk, it's my fault, I should have, but everything we've shown today, JupyterLab as an environment as a whole is an environment that's designed to accept plugins and extensions to allow you to customize it for your workflow and for your needs. And so everything that we've shown, from the text editors to the notebooks to the real-time collaborations to the data grids, the CSV viewers, the GeoJSON, all of those things are plugins into JupyterLab. They're no more privileged than any plugin you would write on your own. So if we can build the notebooks and all of those viewers and everything you see on our plugin system, you can build any plugins you want that do the same things that our plugins do. They can add menu items, they can add into the command system, they can tie into the same model framework. All of that is available to you just like the same way it's available to us. So that was really one of the founding principles of JupyterLab, is taking that hard and fast rule and that nothing is special and everything is a plugin. So
Great.
So, got a few questions. One is, we had the impression that if you have a big investment in current Jupyter notebooks, there's not much of a migration to get them into the Jupyter Labs.
Yeah, that's a really
Does that
good
work?
question. Two of the invariants that we've had with the JupyterLab project is that the notebook document is unchanged. So the document format is completely the same. And the second is that the notebook server is exactly the same. And so the Jupyter notebook server and the document format remain exactly the same. There are some places that users are going to run into some rough edges. One is that the classic notebook has the notion of JavaScript output, and a lot of libraries were using that sort of as a hackish way of getting rich output into the notebook. That's not really going to work in the way that it did previously, although with our new extension system, there's actually a much nicer way of doing those things. So it may take a little while for libraries to sort of port their sort of JavaScript output over to this type of approach.
So a little bit of work maybe for certain corner cases, but generally not much. Let's see. Well, I'll ask a question I've been curious about. So does the Markdown, is the Markdown editor going to have a spell checker for those of us who write a lot and are lousy typists and spellers?
So that is a long standing feature request on both the classic notebook and JupyterLab,
Yeah.
and we're not quite to that point yet, but it is something that we're aware of is a very painful point. I think it's going to be worse in JupyterLab now that we're making it more pleasant to write notebook in this environment.
Right.
And so we're definitely going to have to think about that.
That's already a problem for some of us already, I can assure you. Then what, so the beta is just in a few weeks out. Is there a schedule to go to like a released version in the wild?
yeah, so you can blame me on this one. So we are going to release a beta before this conference, and I found a pretty significant performance problem with large notebooks on Firefox, and I basically said no to the beta until I fixed that performance problem. And so, no pressure on me, but when I get that done, then we'll release beta. So I would imagine within a couple weeks you'll see beta. Yeah.
For the beta?
For the beta, yeah.
And then how long is the beta? Like,
well, so
do you have a guess
we're
at the
considering
period?
beta as 1.0 if you're a user. So basically we're saying this is the product. Please also give us feedback if workflow is terrible for one thing and we've really messed up the UX in one spot, so we can fix that for the primary release. But really we're calling it beta because we might still break some APIs. So if you're an extension author, then consider it beta for you and not 1.0. But if you're just a user and you just want to write notebooks and use text editors and the stuff that we give you by default, we're kind of calling it a user 1.0.
So any bugs would be fixed then in the next
Yeah.
rev, whatever,
Sure.
6 months or a year later then? Or?
Oh, no.
Or
No.
sooner.
We'll bug fix as soon as they come in. And
Yeah.
So,
Oh, okay.
yeah, so we follow Simver, so we might be at 1.0, but if there's a bug, then we'll release a 1.0.1, and you just
All
update
right.
and we'll be done.
And we've been releasing about every 1 or 2 weeks, and I'm guessing that type of schedule will continue. So we'll be pushing out changes after the beta comes out very, very quickly.
So, hang on, let me just check something there. Oh, there's a question, what?
Local
Yeah.
question?
All right.
I was really interested in your collaborative efforts. Is there anything outside of Google Drive? And then also, what are the permission systems that might be in place?
So maybe we should repeat the question for the live feed.
The question was, are we trying to hit any use cases for real-time collaboration that don't involve Google Drive? And the answer is yes. We're starting with Google Drive because they already have APIs for things like permissions and authentication, and they already have the implementation of operational transforms, which is this conflict resolution scheme. So all that makes it easier for this as a place to start, and also it's a use case that we think will be useful to a lot of people beyond that. So yes, but not yet.
Okay. So then there's a question about, for the notebook server for the Jupyter Labs, is it going to run on the same platforms as the current Jupyter?
Yes, absolutely.
So no problem there.
The notebook server that we're using for Jupyter Lab is just the standard, like most stable release of Jupyter Notebook. We do have a server extension that we add to that to serve the JavaScript and the front end files for it. We're also working on an Electron app, so we'll have a native app experience for Jupyter Lab. That actually just uses the plain vanilla Jupyter Notebook server without any custom extensions at all. Jupyter Lab already runs fine on Jupyter Hub in the multi-user environments. Jupyter Lab is now installed on our Docker containers. So if you're using our pre-built Docker containers and images, it's there. So it's basically everywhere the classic notebook is.
Excellent, excellent. So yeah, and I see a bunch of comments that on the Twitter feed where people are very happy about many of the things they've just seen. Was there another in-room question?
Right here?
Yes.
Yeah, thanks. So you have over 100 languages supported. Are you 100 kernels, right?
Something,
Oh, we should
75,
repeat the
100.
So the question was about number of kernels supported.
Are you looking any further than that in terms of having multiple kernels running at once and mingling, merging?
Yeah, so the question is, have we thought about allowing multiple kernels to run at once? And the answer is yes. So one thing you do get in Jupyter Lab out of the box is a much more flexible system for connecting documents to kernels. And so, for example, right here, I can click on this, change the kernel, and actually connect a notebook to other kernels. So there's a flexible way of connecting documents to kernels. I think what you're asking about, though, is multiple kernels for a single document. We don't have that yet, but it's definitely something that's sort of swirling around in our discussions. And there's some people that are starting to think more actively about that. Nothing concrete yet, but
Along the lines of Jupyter, Python, and R all being active simultaneously?
yeah, like some users would like to have a single notebook with, for example, Python and R and the ability to share data frames between the two. And that would be an example. We're not there yet. Some of the work that Wes McKinney is doing with Feather and Arrow, I think is going to be really helpful in sharing data between kernels in more useful and performant ways, but we're not quite there.
And with that, we're at the end of our time here, so we're going to, I think the live feed switches to interviews. Thank you very much, guys. That was great. Look forward to trying it.